Alright, this is to satisfy our requirement for critical subassembly number 1, saying that our rotor mechanism, our peristaltic rotor, turns inside of our housing. So I go ahead and connect the battery terminal. You can see the shoes spinning in there.
So we need to go ahead and have variable control over how long that this motor actually operates for, and this will go ahead and produce different amount of water actually pumped so that the user can specify when they want like 4 ounces, 8 ounces, 16 ounces, etc. So in this case here we have it directly hard-coded into the Arduino. This is going to run for about 1500 milliseconds or 15,000 milliseconds, and so we can do that, quickly show that on the demo here, that you can in fact change it. This is going to go ahead and just click it here, get my finger out of the way. And as you can see, the pump will actually start moving. Like I said, this is hard-coded, but when the proper UI is completely finished, a user will be able to specify exactly what quantity they want, and the pump will run for that amount of time. Switching over to the actual metrics collection of the Arduino section here. So we have, as a simple placeholder for the motor that we don't have, we have a normal low torque DC brushed motor. And so this one has 2 functions. It has to be able to collect the voltage data that the motor is consuming, as well as the time it is running for. And so by doing this, you can actually go over here, and then inside of the internal program that we run in the user UI, it'll go ahead and display these out. Let me go ahead and click this button over here, and this is just going to turn on my motor. And so what we're doing here is collecting the data on how long the DC motor is running for, and then as well as the voltage that it's running for. And these are just some calculations on the current, and then as well as like the kilowatts, or sorry, watts that it's going to run for. So if I go ahead and apply just a little bit of torque to this one, I'm just going to use my finger for this one, it'll start having a lower draw until it eventually reaches a stall. And then as you can see on this side here, we have a stall detection light as well that will turn on and off. And so this one will just go ahead and alert the user, in this case, of a pump clog or filter failure in some of those regards.
Alright, so the next critical subassembly requirement is that this solar panel produces a watt of power. This is our charging board here, so it has a green light if the solar panel is producing a watt. So if I hold my hand over the solar panel, we block some of the light off, you see the light goes out. If I start to move my hand, dim red light, and then if I move my hand fully away, just the ambient light in this room is enough to produce it's like 2.5 volts across the solar panel at 250 milliamps. It's about a watt. This green light is rated for 1 watt, and then when we plug this into our battery, so this red is our output here, plug it into our battery, and now we are charging our battery with our solar panel. Alright, this is just showing that our motor does work when connected to our battery terminals. So our battery is about 8 volts nominal when the 2 cells are in series. I'll show that. So we go to our leads. Yeah, 7.6 volts. They're not quite full right now, but that's about what we get.
Here we can see it lasted for at least 5 minutes.
We've just finished our time lapse. Things are continuous, we promise.
Would you like to touch the battery and show it's not 100 degrees Fahrenheit?
Yes, so we loaded our motor for 5 minutes.
That's still not room temperature.
Battery is room temperature. Love that for